This video will cover 1D kinematic problems in freefall. The problem states there is a sticky ball and is going to be given an initial velocity starting from the ground. The ground is 3.5 meters below the ceiling, and when the ball is thrown, we want it to adhere to the ceiling. Okay, and here we're going to set the coordinate system. In this problem, we'll set the coordinate system as positive y in this direction, and y equal to 0 is the ground. Part A, v naught is equal to 10 meters per second. And the question is asking what is v final immediately after it hits the ceiling, or as it is sticking or adhering to the ceiling. That doesn't mean that the final velocity is going to be 0. After it sticks, then it's going to be 0, but immediately before it adheres to the ceiling, it has a final velocity, and that's the velocity we're looking for. So final velocity and the time it takes for the sticky ball from the ground to adhere to the ceiling. For the first one, for v, we want to use one of these equations which doesn't involve the variable time. The second one has t, and the third one also has t. So we can choose to solve for v, we can choose this formula so that we don't have to deal with time. So it becomes v squared is equal to v naught squared plus 2a s minus s naught. Because in this case it's vertical, we're going to change s to y. So it's going to be v naught squared plus 2a y minus y naught. This is a free fall problem, so the constant acceleration in this case is the gravity. Gravity in this problem is pointing downwards, so it has a negative sign, because we said positive y is this direction, opposite of the gravity, so g is going to be negative. V squared is equal to v naught, we said, is 10 meters per second, plus 2. Now a is going to be negative g. G in this case is 9.8, or always is 9.8. If you're doing problems on the earth, on the surface of the earth, is going to be 9.8. And y, the final y, is 3.5, and y naught is 0. 100 minus 2 times 9.8 times 3.5. If you do the calculation, v is square root 31.4, which is equal to 5.60 meters per second. Now to solve for time, we either use the second equation or the third equation. I'm going to use the second equation. So for time, v is equal to v naught plus at. This means t is going to be equal to v minus v naught divided by a. If we substitute the values, v is going to be 5.6, v naught is 10, and a, we said, is negative 9.8. Then the answer becomes 0.449 seconds. Part B says, now suppose the sticky ball comes to rest instantaneously as it is adhering to the ceiling. Remember, in part A we said the ball doesn't come to rest when it hits the ceiling. It comes to rest afterwards. But now we want as it is approaching, like instantaneously as it is touching the ceiling, it comes to rest. So this means V final is 0. So in order for this to happen, what is the initial velocity that I must give it? That's the problem asking. So just like in part A, I will use the first equation to solve for V naught. V squared is equal to V naught squared plus 2a y minus y naught. V naught is what we're looking for. V we said is 0, v squared, so it's going to be 0 is equal to V naught squared. A is negative 9.8, so negative 2 times 9.8 times 3.5. 8.28 meters per second. Using the second equation to solve for t, we write V is equal to V naught minus GT. V naught is 0. V is 0. V naught, we just solved it, is here. So 0 is equal to 8.28 minus 9.8 times t. This means t is equal to 8.28 divided by 9.8. And the answer is 0.845 seconds.